So we're facing this question before us, and I actually want to show you an alternative way of answering this question. So by reading it, you should immediately recognize that it's a Pythagorean identity question, but there's actually a way to do it without actually having to use the Pythagorean identity. And I think it's maybe a little bit quicker. You can be the judge. You begin by drawing out a unit circle. That is almost a perfect circle. Wow, that was amazing. All right, we can keep on going. All right, I'm dealing with a domain between pi on 2 and 3 pi on 2. Okay, so that means here's pi on 2, here's 3 pi on 2. So I'm either in my second or third quadrant. We keep on going. Now I'm told that sine of x is equal to 3 on 5. Now, do you see how my sign is, it's positive, isn't it? So let's just mark that in. It's positive. For me to have a positive sign, I must be in my second quadrant because I know that I would end up with a negative sign if I was in my third quadrant. So what I'm going to do is I'm going to draw in a triangle here. Let's see if I can do this nice and neatly. I'm going to draw in a triangle. I'm going to call this x. Now, if I know that sine of x is equal to opposite over hypotenuse, and in this case, it's equal to 3 on 5, I can say, well, opposite would be here, which is 3, and hypotenuse will be 5. And now I want to find this unknown value here, which I'm going to call k. Now, to find that, what I'm going to do, and I might just, give me 1 second. I just need more room here. To find what this k is, what I can say is, well, I know that 3 squared plus k squared is equal to 5 squared. 9 plus k squared is equal to 25. K squared is equal to 16. K is equal to plus or minus 4. And just by looking at this, you can see that the cos has to be negative, doesn't it? Because I'm going this way. Therefore, k has to be negative 4 in order for me to get a negative cos out. In my second and third quadrant, I know that cos is negative. So that means I can replace this with negative 4. And it makes sense that it has to be negative. Just look at it. Because I'm going this way. And now I need to find cos of x and tan of x. Well, how am I going to do that? Well, all I have to do now is say, well, cos of x is equal to adjacent over hypotenuse. Well, if this is the angle, adjacent is negative 4 and hypotenuse is 5. Negative 4 on 5. And then if I want to find tan of x, that's just opposite over adjacent. So that would be opposite is 3. And adjacent is 4, and it's negative 4, so I make the whole thing negative. So as you can see, I've answered those questions pretty quickly, and I'm using the knowledge of Pythagoras, but I'm not explicitly using that Pythagorean identity. So some people find this a better way of approaching this question. I'll leave it up to you as to which you'd like better. But there you go. There's an alternative way to answer this question. Hopefully you found this helpful, and I'll see you later.